In this episode, I'll be discussing the acoustical evaluation of an elementary school. This is Noise Engineers Podcast, episode number 17, brought to you by Sound Solutions, an independent acoustical consulting firm found at noiseengineers.com. I'm Bill Holliday. Thank you for joining me on this episode. We're working on a project. It's in San Diego we're working for an architectural firm on the acoustics in an elementary school. The primary issues that are being addressed are mechanical noise, the HVAC, the heating, air conditioning, cooling, ventilation systems, also plumbing, all mechanical systems, sound isolation, impact insulation, and room acoustics. So the HVAC systems are all being replaced. This is an existing elementary school, but they're doing a lot of remodeling to it. We're reviewing the structural supports, vibration isolation. They're mounting the HVAC units directly over classrooms. There's going to be several units, so there's an advantage in that the units aren't as large. It's not one huge unit that's being used. The disadvantage is that they're directly over the classroom. So we have to be careful that the structural supports, the vibration isolation mounts are sufficient to adequately reduce that vibration noise. We also predict the noise radiating into the various spaces. So for a unit located right above a classroom, we're looking at the noise radiating off the unit, going through the ceiling and through the roof, through the ceiling. We're looking at the supply noise going through the ductwork all the way to the diffusers. That's right through the duct system and out the diffusers. We're looking at the noise going through the ductwork into the classroom and then breaking out of the ductwork. Some of the low frequency noise will be breaking out of that ductwork and through they have an acoustic tile ceiling, but through that ceiling into the room. We're looking at the vibration-induced noise as well. And we look at those the manufacturer will give us the noise data for the radiated, the supply duct noise. The return duct noise, we're looking at the same. Now, if they have an open plenum, the return, so the noise getting sucked into the unit, it sometimes will just be an open duct, and in the acoustic ceiling grid, they'll just have these return grills, just an open grill where the air flows back into the unit, or up into the ceiling plenum into the unit. And so that's a noise path as well. And so sometimes the recommendations may be add a silencer, line the duct. It could be for breakout, lag it for a certain amount of distance, wrap it or enclose the ductwork or use round duct. There's a lot of options, but it's a lot easier to do it at this design phase than turn the units on, have a problem, and then have to work with an existing ceiling and try to deal with it later. So it's good that they're addressing this early. We also look at the plumbing issues. So usually bathrooms, kitchen facilities, if they're on walls where there are classrooms or noise-sensitive areas, making sure the piping isn't hard mounted to the studs where it's going to vibrate and shake walls. Make sure that there's some insulation there or isolation there. Any other mechanical units? We're not addressing environmental noise. Sometimes with these rooftop units, you're worried about the noise radiating to neighbors. Where this is located, that's not an issue. We're also not dealing with any environmental sources. So we're not near a busy road or airport where we have to worry about the glass they use on the outside. But that's a consideration for a lot of projects. We are looking at sound isolation, so the noise between rooms. We're in California, so California has guidelines for classrooms, and so we're going to use that as our guidance. There are industrial standards. There are other standards that we could be using as our guideline, but we're required to follow these California guidelines, and they tell us what the sound isolation needs to be. So we look at the proposed wall construction between classrooms or between classroom and different type of room. And we just make sure we look at it and we look it up on our lab tests to see what that sound transmission class is. And if it doesn't meet the guideline, we make recommendations to improve it. And to improve a wall, you can add insulation to the wall. You can add another layer of drywall. You can, instead of just using a single stud, you can use staggered studs or dual studs. In this case, probably the most we'll be doing is adding fiberglass insulation into the cavity. That does a significant improvement for not a large cost. There could be, I don't imagine there'll be other cases. But we could be adding an extra layer of drywall. But we'll make those recommendations before they construct, which is nice. Again, it's better to address these in the design phase than go there. You can test the sound transmission class of a wall and find out it's inadequate, and then you're stuck dealing with ceiling systems and trying to improve the wall after the fact, which can be more costly, more difficult. We're looking at room acoustics, but in just a few places. We'll be looking at them in the classrooms, but all the classrooms repeat. They're a very similar type. So if we evaluate one, we're really evaluating all of them. It's not going to be that difficult. They all have acoustic tile ceilings, so that will be an easy way to get the reverberation time that we want, or get it down below the recommended maximum reverberation time. So you don't want an echoey environment. It's hard to understand speech if it's a lively room. The words tend to blend together and get muddled. And so you want a very dry space, not a lot of reverberation. So they set maximum limits for reverberation time. And you can use wall panels. You could use, well, acoustic ceiling tile, baffles, and there's any number of other spray-on treatments. There's all types of absorptive treatments, but typically in a classroom, the ceiling would be treated because that's a place where you're not getting as much abuse. Kids can still fling pencils into it, but not as much as a wall panel where it's right at abuse level. We are also looking at impact insulation. There are 2 stories of classrooms, one above the other, and we just want to make sure that the footfall noise for the classes above does not disturb the classroom below. So we'll be looking at that construction, making sure the floor ceiling system meets the required impact insulation class. And again, we'll look at that construction, compare it to the lab tests, come up with what it is as far as IIC, and then make improvements if needed. In this case, it's not really adding mass or absorption, it's more decoupling the floor from the ceiling. So a lot of times you have a floating floor or a spring or some kind of resiliently isolated ceiling system so that the impact doesn't transmit through the system. And then room acoustics. Oh, I said room acoustics with the classrooms. We'll also be looking at, they have a multi-purpose room, a cafetorium. So we'll be looking to make sure that that's not too echoey for the environment. Now, in a performance space, you don't want it too dead either. Because if it's too dead, then the notes don't blend together and it sounds very dry, and that's great for understanding speech but not as nice for music. It's nice, singing in the shower where notes are blending together, it's echoey, that they linger in the space when the next note is played. So we'll be looking for a balance because they'll want to keep the noise levels down because it's a cafeteria, and then they'll be doing speech and different types of presentations, plays, so they'll want to understand speech, but we'll have to come up with a balance between speech, between too much noise and too little reverberation time. So we'll come up with the criteria, look at what the proposed acoustical treatments are, and then come up with some recommendations. The other issue is we want to eliminate or reduce undesired reflections, so rear wall reflections or long delayed reflections will cause an echo, or you'll be, or it'll seem like the noise source is coming from behind you or from the side. So we like positive reinforcement, hard surfaces near the stage or near where people are presenting. That can give nice positive reinforcement, make it louder, naturally make it louder for the audience. But we don't want rear walls to be hard and reflective, or back ceilings where you'll get these delays. The rule of thumb on that is if the delayed path or the reflected path is more than 65 feet longer than the direct path, you'll hear it as an echo. So it can be calculated what surfaces should be treated. So those are the issues we'll be addressing. We are waiting on the design drawings, so we've made some initial comments on sound isolation, mechanical systems, general guidelines, but we need further drawings to make specific predictions and recommendations. But we look forward to that moving along. All right, that's all I had. This is Sound Solutions. Well, this is the Noise Engineers podcast, brought to you by Sound Solutions. We are an acoustical consulting firm. If you have any issues, noise issues, environmental, architectural, we're here to help you. You can contact us or find our contact information at noiseengineers.com. My email is bill@noiseengineers.com. All right, take care. Thanks for listening.